in my case, go for move um on SketchUp file, but this on the side. I'm going to import a sketch training model as a plastic, export plastic green apple file, and Assalamu alaikum. Welcome back to our fourth video of our series, which is PVsyst simulation series. So we have discussed the orientation system, tail losses. Let's go to the self consumption. So in my case, I'm not going to use the self consumption because I'm going to feed this into our grid station. So if you have to use this to our like you have a fixed consumption, like you are not going to feed into grid, you are just using it for yourself as a backup or other thing, you can use these features in your hybrid system. Or if you are going to use the system with a zero export device, you can select this option and set the fixed consumption according to your requirement. Okay, so in my case, I'm not going to use this. So in storage, yeah, if you are going to use the hybrid system, you are going to make a hybrid report. You can select these option according to your requirement. Like suppose self consumption, you have to add the parameters of the add the values according to your requirement. Peak shaving and weak grid isolating. So islanding, no, in my case, I'm not going to use the storage, so I will go for the no storage. So I'm have to save the project again. So here we go. Now I'm going to use the horizon. Horizon, we have already discussed it in our first video. So here we are going to select our path horizon 22 June, which is the first, which is indicated in this. It is going from this to this. Now I'm going to use the 4, which is 20 March and 23rd September. So fourth will be this one, and it is our sun path will be like that. And the last one is 7, which is the 23rd December. So 7th will be the shortest day of our earth, or you can say the of our year. So diffuse factor, you can use it points, or you can check these things here. So I'm not going to change anything here, so I'm going to as it is like this. I'm going to click OK. Now near shading, let's do this. So near shading will impact a lot in our system. So here we have some things, like it is saying that near shading command, we have to construct a system for that. Compatibility with orientation and system parameter, active area is our 930 meters square. As we have selected that we're going to use a 360 modules, so which have the areas which will cover the around 930 meters square. Field tilt will be 5 degree, azimuth tilt will be 0.0. So let's construct it and move on. So here we have a plane which is going to north, east, west, or south. So we have to draw our system in south. So I have already drawn my system on SketchUp file, so I'm going to reuse that file for my case. So you can construct it in here too, but I will recommend you that you can make the model on SketchUp and then upload it onto the PVsyst. So here we have round 1 2 3 4 5 6 7 8 9 9 spacing for cleanings, and I have just constructed this on the side of our solar project. Okay, so we will see the shading effect on it. Let's see the shading effect on SketchUp. So it is in winter, so it is moving. So I guess shadow will not impact a lot on it. And in January, let's see, and here you see the shadow is totally minimum in this. So let's not waste our time here. I'm going to import a SketchUp file in our on our PVsyst report. So let's do this. I'm going to first export our file in a 3D model. So I'm going to use a 3D model. Let's save it. I'm going to save it in our PVsyst training model as a plastic, export it. So here we go. Now we have a file like this file. Okay, now we're going to import this file in our PVsyst model. So I'm going to use the file menu. I'm going to use the import a 3D model. So here we go. I have a AZ plastic green apple file. I'm going to import it here. So it is taking some time to import it. Let's give it some time, and here we go. Okay, now here you can see there are scene details. I'm going to I have input my size in inches. I'm not going to change it. Now I have to apply a 180-degree rotation. If I'm not going to apply this, and my building will be facing towards the north south. Now I have to face my building or panel direction to the south direction. So I have to apply the 180 tilting 180-degree rotation from here. Now I have to select the PV object which is denoting out my PV panel. I'm going to select the longi hemo axis variant which is 580 watt, which I have used. Now module orientation will be landscape as here. Then my module orientation is according to landscape. I'm going to use this, and the spacing matters a lot. The spacing around this is 0.02 meter, as I have entered here. If you have different spacing, you can add this here. So let's not waste our time here. I'm going to click OK. So here we go. We have a our SketchUp design imported on PVsyst. Let's see this in rental view. So you can see this view in this. Okay, now let's close it, and you will see it will give a error. Yeah, here you go. It is giving the PV field table row number 1624 is confused or very close to object 676. Let's go to the object 676, and we will resolve this issue too. Now 676 object number 676 676 676. We will just find it 676. Here we go. So I'm noticing that 676 is here. Here we go. Okay, and our this fourth object. So we will just delete these things so we don't get the errors again and again. I'm not going to delete this one or this one. I'm going to delete this one with the 6761. So you can also delete these things so that your drawing don't get overlapped with it. So I'm going to delete these things. I have deleted these things. You can see we have only two objects here. So I hope it will not give the error again. Close it. So are defined in a 3D slightly lower than the modules area defined in the system. Yeah, I have deleted some of the systems, some of the panels, as my modules are just covering the 902 meter square. I have told you that I have erased the 9 panel. It doesn't matter. We can construct and paste it again it. So let's check the simulate the shading animation here. You can see there are some options here. Observer, we are not going to use this. This is the sun position, we are not going to use this. Zone editing, we are not going to. Yeah, shading, you can also check the shading effect here. So it is going to use the 21 12 2024. Okay, here we go. You can see the shading effect here, which is impacted on our system, and it is also drawing a graph, which means shading loss on a clear day being linear loss 0.4%. Okay, and sun height 3 degree, sun azimuth 60 degree, according to our date which we have selected here. So we can save it here. Let's save the file here, and medium file, and okay, I will save it here. Set plastic. Okay, we can save this animation for our record. Okay, I'm going to play that animation for you. So let's wait and see. Here we go. We are, let's now you can see on the top we have the date, sun height, sun element, and linear according to the sun path, and it's 0.07% at the end, which is noting the its shading effect. Now let's close this and move. The shading scene has been modified. Do you want to recheck the distance between the field and the object? This may take some. No, I'm not going to use this thing again. And now I'm going to construct a table, so it is computing the shading factors. So here you go. We have a shading factor table linear for the beam component orientation one. You can see that 2 degree as azimuth 22 degree, it's have some deviations in here. Shading factor for degree is 0.07 and for albedo is 0.051, which is good enough for me. Let's close this and check the graph. So the graph which we have already discussed. Now the dotted line means its shading has a 1% in this region. The this dash line will let's maximize it, means this has a 40% light, this have a 40% loss, which is a huge loss for this. It is actually it is in winter, so we will not going to bother about that thing. It will be clear on the sunny day. Now let's calculate it with slow simulation, which is stable. This one we computed. It will take some time, and here we go. Okay, and okay, we can also overview our system, but we are not going to this. Let's okay it, and here we go. Now you can see sorry, we have a green signal here, and here we have a slightly yellow, which is giving just a warning, but it doesn't matter a lot in my case or in your case. Okay, the red indicates that you have to look for it. Now we will just save the file again. Now we will see our other thing in our next video. Till then, take care. Allah Hafiz.